Hey Opties! Today we're talking about proportions, and we're going to think about a real life situation, and we're also going to apply that to similar figures. So let's go ahead and get started. Proportions. We talk about proportions as a ratio equaling a ratio. So before we can really understand that, we have to make sure we are understanding what a ratio is. So it's a relationship in quantity of two things. This is different than a fraction because you can have it as part to part rather than part to whole. So in a moment when we talk about side divided by side, that's like a part to part. So it's like a ratio. And proportions are when one ratio equals another ratio. And this can be done when you have some sort of proportional relationship between two quantities, meaning these quantities have the same scalar between them, such as a scale factor in the similar figures we've been talking about. Let's look at an example, and I always think cooking is a great way to talk about this. So we're thinking about finding a recipe for brownies, and when we get that recipe, it makes a dozen, but you're wanting to make brownies for your whole entire class because you're super amazing, and your class has 24 people in it. So you have to double that batch. Now, doubling's not too bad, but it's great to look at a simple example like this to understand how we can work with scale factor and proportions to solve much more difficult problems. So if one batch calls for 1 egg and a half cup of chocolate chips, then our 2 batches calls for 2 eggs, and then there are different ways you can figure out how many chocolate chips you need or how many cups of chocolate chips. So if we look down here, we've got method 1, which we want to apply the scale factor. So we know the scale factor is going to be found by the image divided by pre-image. So what we're going to be getting from our enlargement or reduction is going to be 2 eggs and divided by the original 1 egg, which gives us a scale factor of 2. So to quote unquote apply that, that's going to be where we're going to do pre-image times scale factor equals image. So it's one of those formulas we have from our scale factor notes. So we've got the 1/2 cup of chips, and we need to double that because that's our scale factor. So that will give us 1 cup of chips. So we could do it with applying the scale factor, or for method 2, we could solve a proportion by cross multiplying. Now for this example, I probably wouldn't do this. I probably wouldn't write anything down. I'd probably just calculate it in my head. And if it was a little bit weird math, then I might use a calculator. But again, simple examples using the high level techniques will help us when we have to use the high level technique with more difficult numbers. So let's look at this method. We know that 1 egg is proportional to the 2 eggs because they go together. That's the number of eggs. And over here on the right-hand side, our second ratio, the numerator has to be the number of chips that goes with the original batch because the numerator over here on the left was the egg amount for the original batch. So we're just setting things up how they go together. So the denominator is how many chips we're gonna get for our different batch, so when we double our batch. So that's how we have it set up. There are a few different ways you can have it set up, which I'll discuss in a moment, but here's just one standard way. So these little ovals drawn around these variables here, or these values, show the cross multiplication. So cross multiplication is a way to solve proportions. It's a way to solve a fraction equaling a fraction, that way of an equation. So if you have 1 times x equals the 2 times the 1/2. And then we can divide both sides by 1, and we get 2 times 1/2 divided by 1, which is 2 divided by 1, which is of course 1. And we get, again, 1 cup of chips, which is our x value. So let's look to apply this knowledge. We have a pointer pointer that says, with each set of similar figures, there are 4 proportions that can be written with 2 sets of corresponding sides. Now you can include the 3 sets, but if you're just doing a one ratio equals another, there are 4 different ways. So let's look below, let's write them out. If you're gonna map figures mapped to themselves, this is how that can look. 2 divided by 11. So we're looking at our first triangle, our pre-image, if you will, and we're just picking any old side length. We'll start with AB, and then we're mapping it to itself. So we could do 2 over 11, and by the way, we don't have the corresponding side lengths to 11, so it's probably better to map it to 6. We're going to use that 11 for something else in a moment. And so that's the AB goes to BC. So when we fix it on the other fraction, the other ratio, we have to do the image lengths that go with that. So A prime B prime divided by B prime C prime. Now that's pretty obvious that this is a true statement. If you do the math, you'll check to see that both of these ratios are equivalent. But if you didn't know a side length like A prime C prime, you can use this setup like we did with the chips and have one of these things missing to figure out what you have missing. So we could also go the other way. We could do the reciprocal. We could do 6 over 2 is equal to 12 over 4. So it's very similar, we're just reciprocating that. We're flipping those fractions. Now if we take figures mapped to their dilation, that's going to look like, instead of AB over BC equals A prime B prime over B prime C prime, which is that first one. And again, we just reciprocate that, or we'll flip those fractions for the second one. It's going to be like AB divided by A prime B prime equals BC over B prime C prime, okay? So we're taking it from one triangle to the next rather than one triangle to itself. And it doesn't have to be a triangle, but for this case it is. So that can look like 2 divided by 4 equals 6 divided by 12, or 4 divided by 2 equals 12 divided by 6. Now things that won't work. If I change this second fraction to have the B prime C prime as the numerator, that wouldn't work because it wouldn't be lining up the pre-image pieces together. So keep that in mind. You're either going to take a figure to itself or a figure to another figure. And when you do it to itself, the next fraction has to match up. So 2, 6, 4, 12. Or if you go 2, 4, it's got to go then to 6, 4. You got to start back with whatever you started with from the beginning. So we have a question here. What is the length of side A prime C prime? So if we go back to our picture here, AC is 11. We know the scale factor's 2 because 2 times 2 is 4, 6 times 2 is 12. We could also do that by 12 divided by 6 is 2, 4 divided by 2 is 2, and so on. So we know that needs to be 22. So we really just did that by applying the scale factor. However, you can set it up as a proportion. How about we say 2 divided by 4 equals 11 divided by x, the missing side. And you can call that A prime C prime, but sometimes just putting it as a one letter variable helps make the equation look nicer. So let's solve this. We've got to multiply the numerator of the first fraction with the denominator of the second. We're doing that cross multiplication. And that equals the denominator of the first times the numerator of the second. And solving that little equation, we get that x is equal to 22, which is what we already figured out. Number 2 is a really great question, especially if you're into history or just any sort of maps. And this is great if you're thinking about modeling, like a model airplane, a map, which of course is a model of land masses. If you're just trying to sketch something out to put on your wall and you want it to be in the same proportion, then math like this is very helpful. And this tells us a ratio of a map to the actual landmass, and that's 1 inch to 3 miles. So let's write that out, 1 inch to 3 miles. And we want to know how many inches, so that's what we don't know. Are on the map if it corresponds to a 36-mile distance. So you can do it this way. You could also set it up like 3 miles over 36 miles equals 1 inch over X inches. That's another way. And then you could reciprocate either of these. This is taking it like from the pre-image to its image rather than the figure to itself, which is what this is like. So let's go ahead and solve that. I'll just use this one. I tend to set it up this way, but everybody's different. That's why I showed you both of them. So we'll cross multiply. So 36 times 1 is 36. And we've got 3 times x. So 3x. And we divide both sides by 3. And we get 12 is equal to x. So what does that mean? That means that for 36 miles of distance, we'd have 12 inches on the map. All right, Opties, that is it for proportions, using it with similar figures, solving some cool cooking and map problems. See you next time.